sometimes when we're given enough information about a particular scenario that we've derived a algebraic expression from, we can actually input some of the values that we've discovered through our research and all of that into our expression. And this is what substitution is all about. Subbing in or substituting in the information that we've got into our expression, okay, and then simplifying that to find the answer. So in our first part, if P equals 3 and Q equals 14, we're going to evaluate each expression. So we've got 2P plus Q. Now in this case, we actually now know what the pronumerals are. We know what P is, okay, it's equal to 3, and we know what Q is, which is equal to 14. So what we can do, is not knock our camera, is substitute in. So we're going to write it out first. Okay, 2 times 3. Now in this case, I prefer to, so whenever we're expanding like this, we kind of need to write out the multiplication sign, because otherwise if we literally write 2 and 3 next to each other, we're going to mistake that for 23, which is not the case. Plus, now instead of writing Q, we're going to write what 14 is. Now these are all like terms. They've all got the same pronumeral of not having a pronumeral. So what we can do is 2 times 3, which is 6, plus 14, and then 6 plus 14, which is equal to 20. Okay, so we can't simplify this anymore, so the answer is 20. Coming over here, exactly the same thing, we've just got a different expression to work with. So let's substitute in our values. So 3 times 14 plus 2 over 4. So this is where we will need our calculator. So 3 times 14 plus 2. So I always like to break this up into steps, okay, as such. Just makes it easier. I can track my thinking a lot easier. So 44 divided by 4, okay, we know that that is obviously 11. Coming across here, exactly the same thing, different expression. 5 times Q, which is 14, minus, okay, 3 to the power of 2. So let's start by simplifying this off. 5 times 14, 70. Take away 3 to the power of 2. Okay, now you can just put this into your calculator as such. Okay, 61. Just make sure that you understand that this minus 3 to the power of 2, okay, actually means, okay, 70 minus 9. Okay, so 70 minus 9, so 3 times 3 is 9, okay, equals 61. Coming down to the next part, okay, now we've worked with formulas before, this should be nothing new. So the formula for the perimeter of a rectangle is P, which stands for perimeter, equals 2L, okay, which is length, plus 2 times the width, which is we given W. Now we're going to use this formula to calculate the perimeter of a rectangle with length 12 meters and width 9.5 meters. So first of all, let's write out our formula. Okay, really important. Next step is to substitute the values that we've been given in. So 2 times, now what was the length? 12 plus 2 times the width, which is 9.5. Now notice how I'm not drawing a diagram, because I don't actually need to. I'm solving this algebraically. So 2 times 12, 24 plus, again, I like to do it in steps. I like to write it out in steps. It shows the marker, if you're doing this in a test, okay, each and every step that you're doing. The marker isn't having to insinuate what you're doing. 43. Now we can have a look at this formula in a little bit more detail. Okay, let's actually draw it. So we've got the lengths, and we've got the widths. Now, how do we go about deriving this formula? So we're trying to work out perimeter. Now, we could write this out another way because we know that we need to plus all of these together. So L plus W plus W. Now we can actually condense that or simplify it. How many L's do we have? We've got 2 plus how many W's? 2W. So that's kind of how we're deriving this formula. Okay, and then substituting in the values to work out exactly what it is.